Okay, so today we are doing, disconnected. We're doing conditional probability in two-way tables. Okay. So, conditional probability is given in events A and B. Conditional probability is the probability of event B occurring, knowing that event A has already occurred. Two R's. Okay, so my notation is P for probability, then the parentheses, B, this line, and then A. So this is read as the probability of B given A. So I have my conditional probability formula. It's the probability of A and B over the probability of A. And remember, the probability of A and B is found by taking them and multiplying them together, the individual ones. Okay, so A says Mitchell drew a card from a standard deck of playing cards. What is the probability he drew a queen given that the card was red? So what is my first event in this problem? What had to have happened first?
He wants to draw a queen.
What happened first, though? Drawing the red. The phrase, given that the card was red, means that's the first event. And then he wants to get the queen. Okay, so what's the probability of getting a red card?
1/2.
1/2. The probability of getting a queen?
Isn't it 4 out of 52?
Yeah. And, oh, I didn't need that one. The probability of no, wait, I do. The probability of being red and a queen? So these are two separate cards that I'm talking about, not a single card. So when I want to find the probability of an and situation, I want to multiply them together. So 1/2 times 4 over 52 is what?
126.
Okay, so then I want to plug into my conditional probability formula. So I want the probability of red and queen on top. divided by just the probability of red. So the probability of red and green was what?
1/26.
And the probability of red is
1/2.
1/2. So if I'm going to type this on my calculator, I want to type my fractions in parentheses. So I want to do 1/26 in parentheses divided by 1/2 in parentheses. Okay, so what does my calculator give me as a fraction? 1/13. And then as a percent,
7.6.
I'm actually gonna, so when I multiply by 100, I'm gonna round that to a 7 because of that 9 after. So it's gonna be 7.7. Okay, so then my next thing says there are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she takes a yoga class if you know they take a spinning class. So which thing has to happen first? Okay. And then my second event is, what's the second class they're in? Yoga. So what's the probability of being in both spinning and yoga? How many people? There's one sentence that says how many people take yoga and spinning.
60 people take yoga class and 42 people take
15. Okay. How many people just take spinning?
Oh, I thought you were like out of it.
No, I just meant the one that said it both. So how many people just take the spinning class?
48.
Wait, did I say spinning? I wanted yoga. No, wait. I'm not crazy. I did want spinning. You said 48? Yeah. Okay. So then, can I simplify this fraction? I just want it as a simplified fraction.
5 over 60.
Okay, so the next thing we're going to talk about is this table. It's called a two-way table. It's a table that records the data that has two different categories. So the table shows me the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find the probability. So A wants me to find the probability of someone who prefers football given that they are a girl. So what this means I'm doing is I'm finding the probability of girls and football over the probability of just girls. So the word that comes last is the word that goes on the bottom. So how many girls like football? Okay, then I need to figure out how many total girls I have. So I want to add down. So 6 plus 16 is? Okay. And then I just want to simplify my fraction here. Oops, that's not the screen. Okay, so same idea for B. I want boys in hockey. Over what? Hockey. How many boys like hockey? 10. And then how many total hockey do I have? So this one is adding across. There's 26. 5 over 13. Okay. D is another two-way table. This one shows me the results of a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. So A wants the probability of a 7th grader who takes French. How many 7th graders are there in French? And how many total people were surveyed? 150? It said it right here. So this one just wanted a 7th grader out of everyone because it didn't have that special line in it. Okay, so I want to simplify this fraction. One six. Okay. So B is 8th grade, given that they take Spanish. So my top is going to be both 8th grade and Spanish. And my bottom's going to be what? 8th grade or Spanish? Spanish. So, how many 8th graders are taking Spanish? Just 8th graders. And then adding the Spanish column down, you got 68?
Yeah.
Okay. Can I simplify that anymore? Okay, so that one's good. C is the probability they take French and they are a 6th grader. Over what? French or 6th grade? Yep. So how many people take French in 6th grade? 19. And how many total 6th graders do I have? 42. Can I simplify that anymore? No. And my last one is a 7th grader in French. And what goes on the bottom? 7th grade or French? So how many 7th graders take French? 25. And how many total people take French? Okay, and can I simplify that anymore?
No.
19 over 116.
Are you doing the
No. Okay, so the last thing we need to do is make a two-way table. It tells me in a survey 106 juniors and 114 seniors respond. So I know that I have 106 juniors and 114 seniors. Of those, 42 juniors and 77 seniors plan on attending the concert. So, 42 for juniors, 77 for juniors. I need to finish filling out this table. So how do I figure out how many people total attended? What's 42 plus 77?
119.
Okay. And then I'm going to fill out this other total. So what's 106 plus 114? Okay. So now I need to figure out my not attending column. How am I going to figure out how many juniors didn't attend?
Attending minus total.
Yeah, the total minus attending. So I'm going to do 106 minus 42. $64. How many juniors didn't attend? Okay. And I can figure out the total in two ways. I can either subtract the total from the attending total, or I can add down my not attendings. It should give me the same number if I've done this right. Okay. So, now that I've filled out my chart, how many students attended?
119.
How many did not attend?
101.
How many took the survey?